Have you ever wondered why, when you push a wall, it seems to push back? It's a concept that might seem simple, yet it's governed by one of the fundamental laws of physics, Newton's third law of motion. The famed scientist Sir Isaac Newton introduced this law, along with his other two laws of motion, in the 17th century. It states, "For every action, there is an equal and opposite reaction." While this may sound like a riddle, it's actually a profound statement about how forces work in our universe. To break it down, let's look at the components of the law. The action and reaction referred to in this law are forces. Forces in physics are interactions that, when unopposed, change the motion of an object. So when we're talking about an action, we're talking about a force that one object applies to a second object. The reaction is the force that the second object applies back to the first. The equal part of the law means that these two forces are of the same magnitude. If you push a wall with a force of 10 newtons, the wall pushes back with a force of 10 newtons. However, the directions of these forces are opposite. This means that if your push is towards the east, the wall's push is towards the west. It's important to note that these forces always come in pairs. You can't have an action without a reaction. This is why, for example, you can't touch something without it touching you back. Newton's third law of motion may seem abstract, but it has practical implications in everyday life. It's the reason rockets can travel through space, where there's nothing to push off of. The rocket's engines push gas out one end and, in turn, the gas pushes the rocket in the opposite direction. To summarize, Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that forces always come in pairs and are of the same magnitude, but in opposite directions. It's a fundamental principle of physics that governs everything from the push of a wall to the flight of a rocket. This concept, while introduced centuries ago, continues to be an essential part of our understanding of how the world works. It's a testament to the genius of Sir Isaac Newton, whose laws of motion continue to guide scientists and engineers in their work today. So the next time you push a wall or watch a rocket launch, remember Newton's third law of motion and marvel at the simplicity and complexity of the forces at work.